Lesson 6-3, dividing polynomials. All right, so here's one example. We've got 4x to the third y squared plus 8x y squared minus 12x squared y to the third, and all of it is divided by 4xy. This is actually one of the easier division problems because I've only got one term in the denominator, and so what we can do is just split up the fraction. We're going to take each term in the numerator divided by 4xy. So to rewrite it, let's go 4x to the third y squared divided by 4xy. Then you're going to follow the symbols that are in the numerator, so plus the middle term, 8xy squared. Oh no. Okay, sorry about that. Let's see if this works. Okay, so the middle term again is 8xy squared over 4xy. And then there's a minus sign, so you're going to subtract 12x squared y to the third over 4xy. Okay, so everything gets divided by 4xy. Now we just reduce these fractions. So the first one, 4 divided by 4 is 1. And to combine the x's and the y's, remember the rule is to subtract these powers. So remember that if you don't see a power, it really means it's to the first. So 4 over 4 is 1. X to the third over x to the first is x squared. Y squared over y is y to the first, or just y. That's the first term. Then we've got plus, 8 divided by 4 is 2. X divided by x is 1. These cancel out. Then you've got y squared over y to the first, and that leaves you with a y. Then we've got minus 12 divided by 4 is 3. X squared over x to the first is x to the first. And y to the third over y to the first is y squared. Remember, when you're dividing with like bases, you're going to keep the same variable and subtract the exponents to get your answer. Okay, now this would be our final answer. We can't really simplify anything here because we don't have like terms. Okay. Second one, this is a very similar problem, just kind of set up in a different way. So we've got a trinomial, we've got 3 terms in parentheses, and we're multiplying, it looks like multiplying anyway, times 4cdf to the negative first power. Now, even though this looks like a multiplication problem, it really is a division problem. Think about this negative first power. If we were to rewrite this as a fraction, you would put 4cdf in the denominator. 4cdf to the positive first power in the denominator. So we can get rid of that negative exponent by simply moving 4cdf into the denominator of our fraction. Okay, so now each term in the numerator gets divided by 4cdf, and so I'm just going to rewrite it first as separate fractions so that I can work on simplifying them one at a time. So here's the first term. We're going to divide it by 4cdf. Follow the symbol in the numerator, so I've got a minus, then 16cf over 4cdf. Then a plus sign, 4cdf over 4cdf. Okay. Now simply simplify each fraction here and we have our answer. Okay, so we're dividing 20 divided by 4 gives me 5. And then to put the c's, the d's, and the f's together, we're going to subtract their exponents. So we end up with c to the third, d to the first, or just d, and f divided by f gives you 1. In other words, they cancel out. So we get 5c to the third d minus 16 divided by 4 is 4. C over c will cancel out. F over f will cancel out. And notice that I've got a d left in the denominator. That means you want to rewrite this as 4 over d. 4 stays in the numerator, but that d's got to stay in the bottom of the fraction. Then we've got a plus. Notice everything here will cancel out. In other words, we're dividing the same thing by itself, so we get 1. Anytime you divide something by itself, you always end up with 1. So here's our final answer when we simplify this fraction. Okay, now on to the more challenging ones. Using long division. The only time we need to use long division is if you have more than one term in the denominator, like in this case here. You can't necessarily just split up the fraction like we did in the first two examples. So we're going to use long division, kind of like what we learned in elementary school. And I'll show you one example in this video, and we'll surely go over more examples in class as well. Okay, so we've got 9b squared plus 9b minus 10 divided by 3b minus 2. The first thing we need to do is set it up just like we did in elementary school. So 9b squared plus 9b minus 10 is divided by, that goes under your symbol, 3b minus 2. That needs to go out in front. Okay, so this is what we're dividing, and this is what we're dividing it by. All right, now, in order to do this, it's gonna look very similar to what we did in elementary school. You're gonna work left to right here. So you're gonna start with the first term on the outside and the first term underneath here. We've got 9b squared divided by 3b. That's all you're thinking about right now. 9b squared divided by 3b. Well, that would give you a 3b. 3b times 3b is 9b squared. Write it out. We also have this negative 2 here, so now we're multiplying. 3b times 3b is 9b squared. Negative 2 times 3b is minus 6b. Now you draw a line underneath, and we subtract. 9b squared minus 9b squared is 0. Subtract the b's. 9b minus negative 6b. We've got a double negative there, so it's really like adding, and we get 15b. Now we drop down the next term, negative 10. And we start over with the process. So I'm going to use the first term here and divide it by 3b. 15b divided by 3b gives me positive 5. So we're going to place plus 5 on the top of the line here. And then we multiply. 3b times 5 is 15b. And negative 2 times 5 is negative 10. Now, when we subtract here, we're subtracting the same binomials, basically, so we're going to end up with 0. What that tells you is that there's no remainder. And we're done. Okay, so we've got 3b minus 2 times 3b plus 5 gives you 9b squared plus 9b minus 10. There's a real easy way to check this, as long as you don't mind foiling. Oopsies. So if you wanted to check, you would simply multiply your two binomials. Is 3b minus 2 times 3b plus 5 equal to 9b squared plus 9b minus 10? That's what you're checking. Well, if I FOIL this, 3b times 3b is 9b squared. 3b times 5 is positive 15b. Negative 2 times 3b is minus 6b. Negative 2 times 5 is minus 10. Do we end up with 9b squared plus 9b minus 10? Yes, we do, so it checks. And that's how you know you got the right answer. So here's our answer right here, 3b plus 5. Okay, here's another example. I'm going to show you how to do this using long division, and I'm also going to show you a different method that we call synthetic division. Both of them work, but they're a little different and kind of hard to keep track of. So first, using long division, the way that I showed you on the last example. We're going to put x squared plus 2x minus 24 under our symbol. That gets divided by x minus 4. So you're going to start with x squared divided by x. Well, x goes into x squared x times, right? X times x is x squared. And then you want to make sure you also multiply it by negative 4. Negative 4 times x is negative 4x. So anytime you place something above the line here, you need to multiply it through. X times x is x squared. Negative 4 times x is negative 4x. Also notice that I'm lining up the like terms. So we subtract the columns. This gives me 0, x squared minus x squared. 2x minus negative 4x, there's that double negative again, gives us positive 6x. And then we can drop down the next number, negative 24. Okay. Now you repeat the process. And once you finish subtracting, you can start over. 6x divided by x gives us 6. Positive 6. Put that on the top here, and now we multiply it through. X times 6 is 6x. Negative 4 times 6 is negative 24. And you can see that this one worked out well. Again, we've got a 0 for our remainder, so the answer is up here, x plus 6. So that's using long division, and that's how you would set it up. This other method called synthetic division works a little differently. When you use synthetic division, you don't use the variables at all. We use the coefficients or the numbers in front of the variables. Okay, so you want to start with the trinomial here. The coefficients are 1 for the x squared, 2, and negative 24. So you're going to list just the numbers, 1, 2, negative 24. Now we're dividing this trinomial by x minus 4. This number right here is going to be placed in the top left corner, and sometimes we just put like a little, I don't know, half of a box around it. Okay, so this would be your setup for using synthetic division, and then you're going to leave kind of one row underneath here and then draw a line. All right, now let me show you how this works. We're going to drop down the first number, so you drop down the 1, and now what you do is you multiply. 4 times 1 is 4, and that goes in the next column. 4 times 1 is 4. Now you add the columns. 2 plus 4 is 6. You drop it below. And then you multiply. 4 times 6 is 24. And when you add the columns, you get 0. Now this last number here represents your remainder. So we have 0 for remainder. That's good. The next column over, if you kind of go from right to left here, 0 is the remainder, 6 is the constant, 1 is the coefficient of x. So we know our answer is 1x plus 6. And some people like this method better because it's a little quicker, and once you get the hang of it, it's a little easier as well. Okay, so either way, using long division or what we call synthetic division gives you the answer x plus 6. Okay, and we'll be practicing more of this in class tomorrow. I didn't give you any problems to try on your own because we're just going to do some of that in class tomorrow.